So welcome back, everyone, to the Discovery Space Fall webinar series. I'm Michael Gregory from the European Physical Society, and I'm joined by several of our European partners from across Europe. So I'll have them say hi quickly before turning things over to Dimitris, who's the main one leading today, and we'll be joined by Nikos as well. But first, Louisa, would you like to say hi briefly?
Hi, everyone. Really nice to see people coming to these webinars. I hope you enjoy. It's going to be fun to know so much about AI and the Discovery Space platform. Have fun.
Thank you, Louisa. And let's hear from Nikos briefly before we turn over to Dimitris.
Yes, hello from ICCS Greece. Hope you enjoy the presentation about Pendulum. So thank you for coming.
And now the main event, Dimitris, it's a pleasure to introduce you.
Okay, thank you very much. So welcome all to this second webinar in the framework of the Discovery Space project. So today I'm gonna talk to you about embedded assessment of students' problem-solving competence. So Michael, is it okay if I share my screen now?
Perfect. Yes, thank you.
Let's go. Okay, here. So is it full screen?
Yep, it's coming through well.
Okay, so as I said, welcome. My name is Dimitris Koulentianos. I work at the Research and Development Department of Germaniki Agoghi, which is a school in Athens. The school hosts around 2,500 students and 250 teachers. And within the school, there is a dedicated R&D department that we run different projects, EU-funded projects. One of them is Discovery Space. And the main goal of this project is how we can use AI conversational agents to assess students' problem-solving competence. And today I'm going to try to introduce you to this whole concept through the simple pendulum scenario. So those of you who already have a background in physics have a slight advantage, but please keep in mind that the project is addressing all the STEM courses. So not just physics, but also, chemistry, biology, and so on. So I would like to start, with problem solving in the spotlight. And for those of you that, For those of you that did not attend the previous webinar, as I said, our goal is to assess problem solving, and to do that, we need to have first a definition. And this definition is the collaborative problem solving competence as has been defined by PISA 2015. So, and I have the text here in the blue box. So collaborative problem-solving competence is the capacity of an individual to engage effectively in a process whereby two or more agents attempt to solve a problem by sharing the understanding and effort required to come to a solution, pooling their knowledge, skills, and effort to reach that solution. In this context, so, of course, one agent will be the student, and then there will be this AI conversational agent that was introduced also by Nikos in the previous webinar. And we're going to see here today again. Now, how is PISA trying to assess this problem-solving competence? PISA has identified 4 partial abilities. So they say that in order to reach to the solution of a problem, first you need to explore and understand. So here is where the problem solver is exploring the situation. Then you need to represent and formulate. And at this phase, the problem solver tries to identify the parameters of the problem and formulate a hypothesis. Plan and execute, maybe the most important one. So here the problem solver will set and execute a plan to tackle the problem. And finally is monitoring and reflecting. So the problem solver is monitoring the execution of the plan, and it's reflecting to the different stages to validate or reject the hypothesis made in the previous step. And how we want to do that? For those of you in the previous webinar, we discussed about inquiry-based learning. So we want to apply an inquiry-based model in order to assess the problem-solving competence. I remind you this picture here, a seminal work by Pedaste and co-workers, that they have discussed the different inquiry phases, and they have concluded that, the names given should not be absolute, but they can vary. The point is that, that you have a 5-step process, and there you try to assess students' problem-solving competence. Moreover, we want to have formative assessment, and what do I mean by that? I just remind you that it's not just that we want to evaluate, we want also to interfere, we want to intervene and help the student progress to the next phase. So address his misconceptions, the point that the student is facing difficulties before moving forward. Now, for the purposes of this project, we have established these 5 phases shown here. So we have the engagement phase first, where the phenomenon will be presented to the students through an appropriate demonstration, and we try to spark their motivation and their interest in order to work on it and understand it. Then, as I said, we will have the hypothesis phase, and there we will ask the students to make some hypothesis, so to try to explain the phenomenon based on the hypothesis that they are making, and of course identify the crucial parameters for its explanation. The most important maybe of all, it's the experiment phase, and at this point we want to have students perform their experimental work, and for this purpose you will see that we're going to use either virtual or remote labs. And sorry, I get someone has an open microphone. So at this stage, yes, the students will perform the experimental work. And then we go to the data analysis phase, of course, and there they try to make sense from the data that they recorded. So either reject or validate the hypothesis made at the second step. And finally, for some very strong students that, you know, they can move through the different phases without any particular difficulty, of course, there is the reflection phase. And what is the purpose of this phase is just to, you know, give some challenges to the ones that are very strong, and they can move fast through these different phases. And if you see here this plot, we have the arrows with the names of the phases, and here there is this exiting loop. So we discussed that in the previous webinar. Here is where the AI agent intervenes. So there we try to, you know, we see that the student faces difficulties, and the student enters this loop. It will receive targeted feedback, and then we'll move forward. And the same here, the same here, and the same here. So keep in mind that since there is, you know, a dedicated amount of time for the scenario, some students will not go through all the different phases. Now, since we are going to talk about AI, and since we already talk about assessment, we try to have also an assessment model here. Here, since we are addressing, you know, STEM teachers, I hope that you are not afraid by this assessment model. Trust me, it's very simple. So PISA assigned these different weight factors at the different partial abilities. And we have taken these values and we have created this model. So what this model is doing is that, you know, we have a number of questions at each phase to assess the student. So we take and we have a score for each answer. So 1, 2, and 3. And the ones that, you know, have chosen this answer are the low performers. Keep in mind, the student never knows if he or she is a low, moderate, or high performer. Then we have answers with 2 points, moderate performers, and answers with 3 points. So you get an average and you multiply with this weight factor. And at the end, you will get, you know, an overall value for this function here. So we define that, you know, students between 1 to 1.49 are categorized as low performers, those between 1.5 to 2.49 as moderate performers, and the rest of them, those with a score of higher than 2.5, will be classified as high performers. So our goal is to train our AI model, and then when we will run an AI enhanced scenario to see the students' performance to become better and better. So I'm just presenting you that to know what is happening in the background, but don't worry, you will never have to see that. The ultimate goal is what we discussed also in the previous webinar, and it's this plot here. So how do we make a transition from a typical classroom shown there, so that you have the teacher and you have the different students, and there is a single learning path addressing to all of them. So if here you have a high performer, and here you have a low performer and a moderate performer, you see that maybe the high performer is losing interest. The low performer finds this single learning path very difficult, and at the end again he's not able to follow and losing interest. So mainly you try to address here the moderate performers. But What we try to achieve is to have this AI enhanced classroom. So you have the teacher, and then there is the help of this AI conversational agent, and there is an adaptive learning path for each student. So the teacher will provide some initial instructions, will design an educational scenario, and after some data have been accumulated, the AI conversational agent will start, proposing certain activities, certain changes, what Nikos discussed last time. So you have a co-creation, let's say, of an educational scenario based on the teacher and the AI conversational agent. We never want to replace the teacher. The teacher always can either accept or reject the recommendations taken by the agent, but the ultimate goal is to have this, adaptive learning path and try to help each individual student as much as possible. And you can imagine that in a typical classroom with 25 kids, you cannot have the teacher going around every student and be all the time aware of where the student is facing difficulties. So I would like to start now discussing the pendulum scenario. And here, and I will share with you the platform later on, you can see the engagement phase and the exploring and understanding. And the very, very first question that we have in this scenario is that which is the most accurate way to measure the period of the pendulum? And here, as you can see, we give 3 different options. And keep in mind that, more or less all of them are correct. So you see that we have the 1 point, 2 point, and 3 point answers. And of course, the most accurate way is, to measure a time t of many oscillations and then divide by the number of oscillations that were measured. A moderate performer more or less will say that, I can measure several times and take the average. And the low performer will say that, okay, 1 measurement is enough. And again, it's not that something is wrong, but this is the most, let's say the most accurate way. So accordingly, we say, okay, we try to somehow ask the students to make some hypotheses. And here we have 2 different pendula with different masses and the same rope length. And we say, okay, which is faster if there is no friction? And then we will, of course, change the length of the rope and the mass. And we will say again, okay, which one is faster? But the students who have failed to answer here and give this 3-point answer will get into the loop. And here I'm trying to show you that. So immediately a virtual lab will be presented to them and we will say, okay, for a rope of length 0.7 meters and a mass of 1 kilogram, try to measure the period of a complete oscillation and then repeat the above process, but this time try to measure the period of a complete oscillation 4 times and then compare your results. We ask them again some questions, and if they fail again, to recognize the most appropriate way to measure the period of the pendulum, then we give them these explanations here that say that, okay, there are problems with our reflexes when we measure. So if we measure more oscillations, then we eliminate somehow these errors that are introduced by our reflexes. And of course, high performers who have immediately recognized the most appropriate way to move forward, and okay, they can see that, let's say, when I increase the length of the rope, the time of the period increases, and so on, we'll move to the next phase, to the hypothesis phase. And here, we're going to go and investigate the main parameters that affect the pendulum's period. So we say, what can you say about the length of the rope? It does not affect the speed of the pendulum. Shorter length means higher speed. Shorter length means lower speed, and so on. And then we say, what can you say about the bob mass, and so on. So here you see that we talk about speed, and then they should see, okay, connect that with frequency, with period. So it's a very demanding scenario. Usually in Greece, it is addressed for students either in the first class of middle school or in the 3rd class of middle school. But keep in mind that, okay, this is a very, very demanding scenario for the 1st class of middle school. And of course, again, you see that there is this exiting the loop. And then we have this classification of low and moderate performance. Low performers will again start making experiments so that they can see that, okay, when I increase the length, I get a longer period time and the mass has no effect on that. And some guidance will be provided also, depending on the teacher, to the moderate performers. And here, you can see that a learning pathway starts to get created based on the different answers that of course, each student is giving. And keep in mind that, those students that were classified as high performers in the engagement phase might be classified as low performers in the hypothesis phase. So this is not a locked evaluation that if you be classified as a high performer in the very beginning of the scenario, then immediately you continue like a high performer for the rest of the scenario. But at each phase, the evaluation starts from scratch. So in this way, dynamic learning paths are created for each individual student. So now I want to discuss some extreme cases with you to make it even clearer. So consider a student who has been classified as a low performer at every phase. At every phase, he's a low performer. So you see that he or she will start in the engagement phase, will not be able to, identify the appropriate way to measure the period of the pendulum, will not be able to identify the role that the length of the pendulum or the mass have on its period. So this student comes here in this exit loop and perform this activity. Continues to, and of course, some time will be lost here. Then he will continue to the hypothesis phase. Again, cannot, formulate the correct hypothesis. Again, will enter this loop and will come in here to spend some time, continues to the experiment. Still, he may be in the experiment phase, try to investigate the role that the length of the rope has on the period, but maybe he will play with the mass and do something that, it's wrong. So again, he will come in this exiting loop. And I think that by this time, it will be also the end of the 45 minutes that have been assigned to this scenario. So there will be no time to go to the analysis or the reflection. Now consider the case of a student who has been, identified as a moderate performer at its phase. So of course, he will come here, come in this loop, again, perform some activities. In the hypothesis, probably now, he will do a bit better and he can make the correct hypothesis about the length of the rope and the mass. He will perform the experiment correctly, and maybe here in the analysis, he will have some difficulties to interpret the data. So he will again come here in this loop, and there will be no time for the reflection phase. And finally, we have an ideal case, a student, who has been categorized as a high performer at each different phase. So you see that this student can move forward without any difficulties. And here at the reflection phase, I will present that in a while. We ask the students to work with a remote lab and then add a mass on top of the mass and try to see if that has any, effect on the pendulum's period. And of course, as I said, this is for a student that is always low, high, or moderate, but real life is a bit more complicated. So I would like to discuss with you briefly these results that are from the implementations that we had in our school in Greece. And of course, last year, we also invited some teachers to help us, and they implemented the scenario in their schools in different parts of Greece. And you see that we have this Sankey plot. Now, before I say anything, please let me say that because of the nature of this scenario, we merged two phases, the analysis and the experiment. So it's here. But for all the scenarios that you will see in the platform, there are always 5 phases. That was the first one to run, and it was a bit difficult, to have one experiment and then the analysis. So we merged the phases. If you see 4 phases here, it's because of that. But the main concept is still the same. So Nikos discussed how we can visualize our results using these Sankey plots last time. And you see that, okay, students start here. Some will exit the engagement phase as low performers, but will transition to high performers. Others will go, and transition and become moderate performers. And some will continue as low performers. And the same holds for each category, for the high performers and for the moderate performers. Now, if you see this bar to be much larger for moderate performers, I remind you that the range for a student to be classified as a moderate performers, it's much larger. And this was, happened intentionally because, okay, usually in a typical classroom, the majority of the students are moderate performers. You have some low performers and you have some high performers. That was the idea behind that. You can always do your own analysis with your results and see, if you have in mind, you can see that. So you see that the students transition as they move through the different phases. There are some very strong students here that are always high performers, and there are some, weak students that need help that are always low performers here. Also, a low performer in the reflection phase, might be a high performer here, but because these things are very challenging, the student found some difficulties. And then there is this other plot discussed by Nikos also last time that you can get directly from the platform that shows the times spent at each different phase. Sorry for the Greek because I get the results in Greek directly because the scenario ran in Greek. This is the engagement, the hypothesis, the experiment, and the reflection. And as you can see, the scenario is somehow front-loaded for low and moderate performers. So they spend a lot of time in the early phases of the scenario and becomes back-loaded for high performers as they need to spend much time in the experiment and in the reflection. Keep in mind that, for some of the students that have been classified as low here and here, there is not a lot of time. Now, as you saw last time, the point is to get this data and train an AI model. So once you will have your scenarios, or you can find the Pendulum scenario in the platform, you will see that there is this button here, Scenario Metrics and AI. And this will give you some recommendations, as Nikos discussed. And you can see all these recommendations here in the proposals. And of course, it's up to you to either accept or reject these proposals. So you can thoroughly revise them. The AI, based on some criteria that have been passed by the ICCS team, will suggest a few things to you. So it's up to you to either reject or accept this criteria. And for example, I want to show you here, for the Pendulum scenario, the typical learning path that was initially designed by us. So you see that students in the reflection phase, especially, that we got a lot of recommendations, come here to activity 9. And then, they get some explanations, the moderate and the low performers, for the period dependent on mass. They get another explanation and they continue here at activity 10 and move forward again. But here, the AI system tracked some, difficulties of the students based on the time that it took them, or how many of them had been classified as high performers, moderate performers in the previous phases, and so on. So these are, again, you don't care about that. You just want to see the recommendations. And so after that, it designed another activity here for the low performers, and another activity for moderate performers come this way. So there is an explanation, then there is another activity called pendulum period concept, and then they move forward to activity 10. And this was not done by us. This was completely done by the AI assistant. So this was after the system was trained and started to suggest activities in order to help students become better. So you can see here are these activities. So period dependent on mass. So it's a question according to your measurements at the very end. Does the period ultimately depend on the mass? And then, of course, there is another question: which of the following factors affect the period T of the simple pendulum? And this was suggested because at the end we give also the formula of the period to the students, and we try to see if they can handle this mathematical formulation. So this was a very encouraging result for us when we saw it. And by that, I would like to thank you at this point. If there are any questions, I will be happy to answer now. Otherwise, we can move forward and discuss a few things on the platform. Oh, sorry, I stopped sharing, but Michael, I see some questions on the chat.
Yeah, there were a couple of questions. I think Louisa did a pretty good job answering them, but maybe you have some input as well. They were more or less about how well whether there's a risk of the pathways leading to the lower performers not learning enough, or how it's balanced with the different streams.
So please keep in mind that this is always depends a lot on the students that you have. So the system will start acquiring data, and based on this data, the recommendations will come. As I said, it's made in a way that most of the students will be assessed as moderate performers, because usually this is the case, but this is up to the teacher also. If he sees that, many students, are classified as high performers, you can change the scenario. If you see that a lot of the students are classified as low performers and you don't expect that again, it means that the initial design of the scenario has some bugs. And before you activate the AI assistant, you need to spot these bugs. So that's why we get this data, and that's why we try to see that the assessment is indeed correct. Now, once you have this data, then you go for the AI assistant. So if this is not answering the question, please let me know, or Luisa, please feel free to interfere. And Nikos, about the AI, if you have some comments here, also it's a very good point.
There's a second question that I didn't have time to answer.
Okay.
It's a good one
tricky.
as well.
It's a tricky one. How
Okay.
long will it take an individual teacher to create this kind of learning paths for a single lesson?
Okay, this I can answer, don't worry. I can tell you that if the platform is very, very friendly, but maybe the first time that you will go there and try to create your own scenario, you might get a bit, overwhelmed or, find it difficult. But if you have the scenario in your mind, if you have the scenario in a piece of paper and you say, here, I want to ask that, that, and that, and I want this kind of students to do that and that and that, then it's, trust me, once you start becoming familiar with the platform and you have the scenario in your head, because this is the difficult part, it might be even 2 hours to create a very, very complex scenario. But again, if you want to start creating a scenario from scratch, this following this inquiry-based model, this can take time, of course. Yes, this can take time. So it depends what you want to do. So it's a bit tricky to, think, in this phase, I want to do that, in this phase, I want to do that and that. But if you have that in mind, then it becomes much easier. And the platform is very, very friendly, I can tell you that. Now there is a comment, so we need the repository. I don't know, what do you mean by that?
Examples, I think.
Okay, there is a repository.
Which is very important.
If you access the platform, you can see all the scenarios there. You can see how they have been structured. And of course, if you start creating your scenarios, you can copy some activity. So if you feel that an activity, for example, for physics, for, I don't know, a specific subject of physics should be like that, and then maybe you can take it also for another subject, and then yes, you create a repository in terms of that. There is a repository in online labs that are already in the platform. There is a repository of remote labs. So a lot have been done, but we will be more than happy to have your feedback and do even more.
And we'll get to it more later, but in case it's useful, I've added the link to the platform.
Yes, of course, of course. Let me say at this point that also we presented that last time, Nikos presented that there is a dedicated manual on how to use the platform. And you can reach us, of course, reach me through Michael or my email or through, I don't know, I will be happy to contact with you and, help you. And please have a look on the scenarios that are already there, because some of them are very complicated and a lot of things have been done there. So, for example, there is the mission to Mars, Luisa, and there is the photoelectric effect. So very demanding subjects that, complicated scenarios are already on the platform. Okay, so there is another question. Can you describe the steps of designing a scenario and the tools? Yes, the steps are, again, it depends on what you want to do. The engagement, I think it's a tricky one, because you need to find something to spark the interest of the students. So either you will have to be based on previous knowledge, or sometimes, we created recently some scenarios about the photosynthesis and the pH. So we try to show them some videos and some demonstrations to introduce them, and then we start asking some questions and so on. Then in the hypothesis, you start somehow pinpointing the parameters to them and ask some questions about how they affect, what the phenomenon that you are investigating. In the experiment, you will need to use a platform with online labs, such as FED Colorado, for example, that we have already some labs on the platform, or any other digital lab that you want. And from there, things become easier, because then, based on the experiment, you ask the questions. So more or less, these are the steps. Again, if you have a scenario in mind that it's in physics, of course, and we can help, feel free to share it with us, and we will be happy to help. Or, you can consult the scenarios that are already there. But this is usually the idea. So you can use a video, you can use something to spark the students' interest, and then start asking questions. So you don't want to start, hitting them directly with equations and all these things. You first want them to have an experiment and then try to, make them, guide them towards a conclusion.
And I just add that it doesn't
Yes,
have
of
to be
course.
physics, it can be
No, no.
chemistry, it can be science.
Yes.
It's not restricted to physics, although there has been a bias towards
Yes.
physics.
Not only it doesn't have to be restricted, sorry, Luisa, but we encourage those of you that are not physicists, to create your scenarios in the platform, because right now it's very physics loaded, as Luisa said.
Exactly. And the other thing I would just like to add is that in not the next webinar, but the other one afterwards, we will try to explain like step by step what you should take into account when you are preparing a scenario. So I think we will explore more in depth how to create or how to adapt and how to create scenarios. So if you keep with us for the next webinars, I think we will help a lot. This was a very good explanation, a general one, so that you understand what is needed, but we hope to help you in 1 or 2 webinars to be more proficient in creating or adapting, which we suggest to start with adapting.
And actually now I get a nice pass from Luisa. I would like to share again my screen and show you a bit the platform and how does it look in the platform. So share. Michael, can you see my...
Yes, we see the platform on your screen.
Perfect. So yes, so this is the pendulum scenario. You can find it here. Nikos discussed that. If you come in the platform when you create your account, you will see here in the authoring tool all the available scenarios, the public ones, and some of them they say here org only, so it's your organization that sees the scenarios. But if, for example, I come to the initial pendulum scenario, let me find it. Give me a minute, please. Here. So I can press view. So here you see that you can update the scenario. Okay, you can create a face. Now all the faces are here, of course. And you can have this option that I discussed before, scenario metrics and AI. What is very useful is that as you create your activities, the platform is immediately giving you this graph here. So you can see the paths and you can see what the low and the moderate performers are doing as you progress. And not only that, but you can come then here once the scenario has been created, for example, and you want to see the experiment, you can come here in the experiment phase. And here you see that there are the instructions about how to perform the experiment. And here I have the FET Colorado Pendulum Lab. And the students can directly work here and do all the measurements and everything. Nico, would you like to comment briefly on this AI evaluation here? Do you have something to add on that? Because I don't want to miss a point.
Yes. So according to the student data and the previously created activities and the next ones as well, we use the information that are in scenario to generate some initial evaluation from the AI model, just to pinpoint some and highlight some of the value of the activity. So it's probably like a small summary of this activity, its position in the phase, and according to the previous and the next activities as well.
Okay, thank you very much. And now I can go back to the phase here and back to the scenario. And I would like to also show you the remote lab. So this should be in the reflection phase here. So activity 9, if I'm not, yes. And here you can see that Labsland is a collaborator of this project. So we have free access to the remote labs. So here I will press access. It will be redirected, yes, and we have the pendulum. So there is a short introduction, okay, here I can say, and here I can add. So you see what I said with you, that by this point, students, they have done all the experiments, they have played with the length of the rope, they have played with the mass. So high performers and moderate performers have identified that, as I increase the length of the rope, the period is increasing and that the mass has no effect. So here we come to challenge this conclusion and say, okay, I will add the second can, I will add the Coca-Cola can, for example, above the bob mass or on the bob mass. And then we ask them to do the measurements. So you can see if I click here, yes, and then I will say the parameters, okay. And finally I go to the observation and you see that here they can start measuring the time again for this specific pendulum that has the Coca-Cola can above the bob mass. So there it's a point that because the center of mass is changing, you will see that the period is changing because this is equivalent to a change in the length of the rope, and some of them get confused and they say, oh, you know what, yes, I was wrong, and finally the mass affects the period. There are some very, very strong students that will identify even that and they will say, no, my observations are correct, but it's because, the center of mass that is changing and this affects the length of the rope and the mass does not affect the period. So, as I said, you can use this remote lab or any other remote lab from Lapsland for your purposes. And again, you see that you have the AI evaluation here. And what else? Yes. And if I go now back to the authoring tool, here you will have the AI assisted scenario now that you can, the version 2, that you can start working. So this is in Greek, I'm sorry, but here you can see, let me go back, you can see again all the different faces. Nico, I think we have that in English also, right?
Yes.
Okay,
Yes.
let me go. Yes, pendulum scenario AI assisted. Yes, here it is. And there again, you can see now all the different activities that have been proposed and created by the AI companion. And you can also now apply, implement this scenario with your students and finally see if, they're becoming better. And again, this is an iterative process, of course, in AI. So each time you collect new data, you train the algorithms, you get new activities. There is an open discussion now on whether or not we should also give some criteria so that students that have been both classified as moderate or low then do different activities based on their times, their previous evaluation and all that, but we are not there yet. So yes, are there any questions at this point now that you have seen the labs and everything? So I will stop share for a while to see you.
So there was a question about the access code, which Louisa and I have shared in the chat. And
Okay. Okay, so let me go briefly on that. Share. Yes, the access code, of course, Nikos can say much more on that, has been introduced so that, we don't want random students or non-teachers to create an account in the platform. So when you will say create an account, you need to provide this access code in order to get a teacher account. Correct, Nikos?
Yes, exactly.
Okay.
Yeah.
Okay. And then, as Nikos explained the previous time, once you have your teacher account in the platform, you need to come here to the organizations and create a new organization. Maybe some of you have already an organization there. Here, for example, I can show you for our school, Ελληνογερμανική Αγωγή, that here you will have a very short description, a logo if you wish for your school, and then all the members, and there will be an admin, so you can add more members from your school. So with the access code, you get this teacher account, so you can come here in the student view. For example, you can see the scenario and start running the scenario, what Nikos also discussed last time, and you will see again. I will go here and you see. So I will press start. I will press restart now. Keep in mind that the restart option is not available for the students, just for the teachers. So students cannot go back to a phase. And here, what is the ideal way to measure a pendulum's period? And then, okay, I will choose the correct answer now, and then I will get the next question. So this is about the platform. Here you have the documentation and tutorials. We discussed that again last time, but please, you can find it in English. there, and we explain everything in detail, how you can create your account, how you can create your scenario, how you can access previous scenarios and all these things. And of course, our emails are within this guide. So for any difficulties that you might have, either pedagogical or technical, do not hesitate to contact us. I don't know if there are more questions, I will be happy to answer them. Or if if something was unclear, to discuss that again, please let me know. I understand that people might want some time, to digest these things and come back with questions. But I would like to have, we don't have much time left, but again, if there are some questions, let me know. And if questions come up after this session, again, do not hesitate to contact us through an email. Okay, so Michael, I don't see any questions. If you have to say something for the next series, or
Yeah. I'll give a brief plug for my session next time. So don't miss next week's webinar, where I'll be presenting that one. I'll be presenting on the Zookeepers of the Galaxy learning scenario, which is one that guides students through using Google Teachable Machine to make a machine learning model to learn about different shapes of galaxies. So that's one that resulted in a lot of ways from the artificial intelligence and machine learning online workshop series we ran last fall, and a way of giving one example of how teachers can teach students about one aspect of artificial intelligence to students. So for that one, I'll put the link to registration in the chat in case you haven't registered yet, and in case that plug inspired you to join that one. The following week, as Louisa mentioned before, she'll be presenting and giving a couple more insights into how you could be using the platform yourself to create or modify scenarios, going from kind of the story of how the scenario she's presenting was created. And then through October, the shift will focus into enabling you to adapt things and create things for your own classroom. So that's kind of where things are going with this. If you're new to this, and if you missed last time, which was an introduction to the platform, that seeing the recording of that could answer a couple of questions. We've hit a couple of the delays, so the recording isn't online quite yet, but it'll be on fairly soon, as well as the recording from this one. But of course, if you're at this session, you probably don't need to watch the recording of this session again. So I think that's all the plugs I had for upcoming webinars. If anyone's thought of any other questions or things you want to say before we close off, we'll take maybe 30 more seconds to see if there's anything people want to say for that. After that, is there anything Dimitris or any of the partners want to say as any last words to the participants?
Oh, thank you very much all. Thank you, Michael, for organizing that, and thank you all for attending that. And what I will say for one last time, I said that several times, is that do not hesitate to contact us if you have any, questions.
That's a great. Oh, sorry, Louisa, go ahead.
I was just going to ask if the participants could say if it's the first time they are looking at the platform, or if they have any experience, so that we have some idea of how much you can follow, because the presentation was very clear, but it's different if you have already been inside the platform or if it's the first time. So if you could use the chat just to say if it was the first time that you're looking at a scenario, or if you have already seen something about it, because I think it's much easier after you have already looked at it, even if you haven't implemented it with the students. But the way you look at the platform is quite user-friendly. But of course, the first time you look at it, it might be a little bit more overwhelming.
Okay.
So we do have some first timers.
Oh, and I see a comment here. Sorry, Luisa, that I missed the previous one. So yes, I wanted to ask also how many of the participants were in the previous webinar that, the platform was introduced.
Exactly.
Also.
Yeah. Just for us to understand how much they are already prepared to listen to us, or if it's all new. I think that also helps us know how to proceed for the following webinars. So we do see that some are looking at this for the first time. Yes. Yeah. So we do have. I would say that it would be nice if you could register and look at the platform before next webinar with Michael, since I think Michael is going to put you doing things, right?
Exactly, yes. My background as a teacher, I can't resist that.
So you will be asked to be inside the platform and following the steps, so that you will be you'll have a feel of how it is to be a student with one of these scenarios. I think that's important for those that I hope we will see again next week. And that was it that I meant to say.
And just along those lines, it's great to see that a lot of people are new and they're learning about it and taking interest in this. And the overall plan for this webinar series is to start with some of the basics, showing you some of the most popular scenarios, how it works from that point of view. And then once you have an understanding of that, then empowering you to think about creating your own scenarios. But it wouldn't make sense to have you try and create one in the first place if you don't yet have any experience how they work and how it works in your classroom. So that's kind of where we are and where we're going with this as well. I think that's all I have to say. Anyone feel free to interrupt if there's anything we've missed or any last thing you think of. But it was great to have Dimitris along presenting what's the most popular learning scenario we have, and great to be joined by Luisa and Nikos as well. And of course, really great to have so many teachers joining from really everywhere. So, oh, that's a question just before when. Excellent that you joined for the first time. It was a great experience. Thank you. So thank you again, everyone, for being here with us, and have a great evening, everyone.
Thank you.
Goodbye.
Bye-bye.
Thank you. Goodbye.